So let's look up. Let's look at anomerism in monosaccharides. First, anomerism is a phenomenon whereby compounds having the same structure differ in only the anomeric carbon. The anomeric carbon is carbon 1. Carbon 1. So if the difference is in the anomeric carbon and all other ones remain the same, we call them what? Anomers. Do you understand that? So they differ only in the anomeric carbon. Take for example, if you have something like this, please note that anomerism is only experienced in cyclic sugars. That is the Haworth structures of sugars. Now, if you have this structure here, and you have another structure here, now let's observe these two structures. If you notice, this is the structure of glucose, the same glucose we've been drawing since. The one we do like this. Now, this one is glucose. This is also glucose. But the difference is this one is the straight chain, right? While this one is the cyclic form. This straight chain is called the Fisher's projection. Fisher's projection. While this one is called the Haworth formula. This is the Fisher's projection, while this is the Haworth formula. Now, anomerism in monosaccharide is only observed in the Haworth formula, the cyclic form. Are we following? Anomerism is not seen in the Fisher's projection. Now, in the Haworth formula, if you look at this, this is glucose and this is still glucose. If I'm numbering this, my numbering starts from here. This is carbon 1, carbon 2, 3, 4, 5, and 6. If I'm numbering this, the same thing. 1, 2, 3, 4, 5, and 6. Now, anomeric carbon is carbon what? Carbon 1. So when you hear anomeric carbon is just carbon 1. Now, if the difference in the structure is seen only in carbon 1, we say they are what? Anomers. Take for example, if you look at this, carbon 1, the OH here, is it up or down? The OH here, is it up or down? Up, right? Let me clean this one. If you look at carbon 2, is the OH down or up? Both down, right? Both up, both down, and same thing. So if you notice, the difference here between this molecule and this molecule is in the anomeric carbon. It's in carbon 1, right? The difference is only seen in the carbon 1. So we can say these two are anomers, right? But in life, will you like to be up or down? You would like to be up, right? So it is better to be up than down. If the OH on the anomeric carbon is up, we call that beta what? Glucose. But if the OH on the anomeric carbon is down, you call it what? Alpha glucose. So this was originally, this was D-glucose. So we can say alpha D-glucose. And we can say beta D-glucose. So note, it is better to be up in life. So if the OH on the anomeric carbon is up, it is what? Beta D-glucose. If the OH on the anomeric carbon is down, it is what? Alpha D-glucose. So this is how anomerism is seen in monosaccharides.